Let's factor some trinomials. Now, all of the ones in this video are going to have a lead coefficient of 1. So in this example, I've got x squared plus 5x plus 6. Because it's a trinomial, I know that I want to factor it into the product of two binomials. And by that, I mean that I've got two terms inside of each of these parentheses. So I want to start by really figuring out what is going to go in this first spot for each of those parentheses. And the first spot needs to multiply, that's an f, needs to multiply to be that x squared. Okay, so what times what is x squared? That's going to be an x times an x. So I've got that one checked. And I also want to make sure now that the last spot, so this is going to be the last and the last, I need those last two to multiply to be a 6. Well, I've got some choices here. So I'm actually going to move through a couple of my choices. I want the product to be equal to 6. So the product is going to equal 6. And I want their sum to equal that middle term. So this is my middle term here of 5. Okay, so I'm going to go through some options. I'm going to go through one that actually isn't going to work, but 1 and 6 multiply to be 6, but 1 plus 6 is equal to 7. So that's clearly not my choice. So how about 2 and 3? 2 times 3 is equal to 6, and 2 plus 3 is equal to 5. So that's the pair that I want. These are both positive, so I'm going to record those signs, a plus 2 and a plus 3. Now this does give me my factorization, and it gives me my answer, but I can double check x plus 3. Now, as I go up to each of my values, I already guaranteed that the 6 is good. I also already guaranteed that the x squared works with this factorization. What I really need to do then is to check and make sure that that 5x works. Now, I had a colleague that called this checking over the rainbow. It's goofy, but I promise it works every single time. Let me grab a different color so that you can see what I'm doing here. As I'm checking over the rainbow, I'm checking my middle terms here. I'm going to do that outer product, x times 3. That's going to be a 3x. And then let's do that inner product. 2 times x is a positive 2x. I add those together and I get my 5x. So I know that my factorization works. Now I know that I said each of these was going to have a lead coefficient of 1. This one doesn't, but it happens to be a GCF. So every single time you're factoring anything, you want to see if you've got a greatest common factor or a GCF in all of your terms. And in this case, 2 divides into the 2, the 10, and the 8. So I'm going to divide each of my terms by that 2 and then slide it out in front as my GCF. So 2 lives out in front. Let's go ahead and record what we've got left inside these parentheses. So 2x squared divided by 2, I can cancel those 2's, I get an x squared. And then negative 10 divided by 2 is a negative 5, and I've got that x. And then finally, 8 divided by 2 is a positive 4. Okay, so now we're ready for our factorization. So I know that I've got that GCF of 2 out in front. I'm going to try and not forget that. But because I have a trinomial inside those parentheses, I know that I want to factor it into a binomial times a binomial. Okay, so here we go. I need to make sure that I've got an x squared in these first terms. So this is first. So what times what is equal to x squared? That's going to be an x times an x. Now let's go ahead and work for that last term. Okay, so for the last term, I need their product, so this is going to be last here, I need their product to equal 4, and I need their sum to equal a negative 5. Okay, so we could do a 2 times a 2 and put those into our last 2 spots, but 2 plus 2 is equal to 4, so that pair is out. We could also do a 1 and a 4. If I do a positive 1 and a positive 4, 1 plus 4, I'm so close, but I get a positive 5 instead of a negative 5. Okay, so this one's out. I could also do a negative 1 and a negative 4. Okay, -1 times -4 is +4, and if I add those two together, that's a -4, it is a -5. So that's exactly what I want in those last positions. So for those last positions, a product of 4 and a sum of -5, I'm going to use my pair -1, -4. The order here does not matter. Let me write this all in black. This is my answer, x minus 1, x minus 4. We could go ahead and check it by multiplying everything through to make sure that we get our original trinomial, or we could check over that rainbow. -1 times x is a -1x. X times a -4 is going to be a -4x, and that gives me that -5x. So I've verified that middle term. Okay, here's another trinomial. If you feel like you're getting the hang of it, go ahead and pause and then catch up with me, or you can follow along with me here. Now we've got a trinomial, so anytime I see a trinomial, well, anytime I factor anything, I look for a GCF. There is not a shared factor in all three of those terms, but it's a trinomial, so I'm going to set this up into my two binomials. Okay, so I'm going to start with the x squared. That's going to go in those first two positions. So I want an x times an x. And then I want that product of a -18, so multiplied to be a -18 this time, and then I want their sum to equal a +3 in the middle. Now I could start to go through these options, right? And I could do 2 and a 9. They're never going to get me to a 3. And I also know because I have a negative on my 18, one of these needs to be a negative and one needs to be a positive. That's still not going to get me to a sum of 3. I can cross that out. I can also cross out the 2 and the -9, that gives me a -7. Okay, what else multiplies to be 18? How about a 3 and a 6? So 3 and a 6, but I know that one of them needs to be negative, and I want a +3 in the middle. So I'm going to make the 3 negative and the 6 positive. -3 plus 6 is equal to +3. That is the pair that I want. Let's go ahead and put that into our factorization, and in any order, it doesn't matter. I'm going to put my -3 here, and I'm going to put my +6 here. Now with this factorization, you could also do a quick little check there of your middle terms or over the rainbow, right? That would give you a -3x, and then a +6x, which gives me my 3x in the middle. I've got one more, and this one's for you. So pause the video, see how far you get, and then go ahead and catch back up with me, and let's check our answers together. Okay, so as I'm factoring this one, I'm going to set it up. There's no GCF. So I'm going to set it up into two binomials, and I'm going to start filling in both spots inside my parentheses. I'm going to start with my first and my first. This is going to be an x times an x. That guarantees my x squared in the front. Now to get the last positions, I need these two. This is my last and my last. I need these to multiply to be a 2, and I need them to add to be a -3. Now the only way that I could multiply to be a positive number and add to be a negative number, I would need a negative times a negative here. So I know as I'm going through my choices, and there's not a lot, I need two negatives. So certainly 2 times 1 is equal to 2, but I need them to add up to a -3. So instead of 2 and a 1, I'm going to do a -2 and a -1. -2 and -1, if I add those together, is my -3. So that means that inside of my parentheses, I need the -2 and the -1, and that's my factorization. Be sure and watch my next video. I've got a great strategy for you for tackling trinomials that have a lead coefficient that isn't equal to 1. I'll see you next time.